So, good afternoon, everyone. So, today we are going to study flux linkage equations of induction motor of stator and rotor using DQ transformation or using path transformation. Okay. So, let us consider two-pole star connected symmetrical induction machine. Okay. So, this is our stator. This is the stator, okay, and it has got these three windings A dash, B dash, C, and C dash. Okay. The winding arrangement of the two-pole star connected symmetrical induction is shown here, and the stator windings are identical. Okay, the stator windings, this is for stator and this is for rotor. Okay, so the stator windings are identical, sinusoidal distributed windings displaced by 120 degree and with NS equivalent turns. Okay, so each phase has got NS equivalent turns and RS is the resistance. Okay, so here these are the stator windings, three-phase stator windings connected in star. Okay, and these windings are displayed by 120 degree space. Okay, so and this is the axis of this winding, axis of phase. Phase winding A. Okay, so this is A axis, then A phase A winding of stator. Okay, so S is for stator and R is for rotor. Okay, so similarly, rotor winding. Three rotor windings are shown here. Okay, so and its resistance is RR. So this is symmetrical winding. Okay, so each winding has got same resistance R. Okay, and the number of turns, equal number of turns is NR for the rotor winding which is connected in star. Okay, so current flows in A winding is phase A is IR, in B phase IBR, and in phase C is IC. So this will be S, IAS, IBS, and ICS. Similarly, in case of rotor, this is IAR, IBR, and ICR. Okay, so voltage across this phase is VAC, across this VBR, and this is VCR. Okay, similarly VAS, VBS, and VCS. S is for stator, and R, small r is for rotor. Okay, and let us assume the AS axis and the axis of AR will be displaced by an angle theta. So this is AR axis. Okay, like this. So the axis of the rotor, okay, so it is displaced by angle theta. Okay, so axis of AR is displaced by AS by theta. Okay, and the positive direction of the magnetic axis of the stator winding coincide with the direction of FAS, like the MMF produced in this winding, AS winding will be in same direction. So this will be FAS, MMF produced in this coil, and then in this will be in FCS, and this will be FBS. Okay, so these are the MMFs, which is along A axis, AS axis, BS axis, and CS axis. Okay, so this will oscillate in this axis from minimum to maximum, then again to 0, then in maximum negative direction, and then 0. So MMF of the stator winding is in same phase of the magnetic axis of the stator winding. Okay, so now we shall write the voltage equations. Okay, so here we have 6 coils, 3 coils for stator and 3 coils for rotor. Okay. So the axis of the rotor phase, so this is axis of the rotor phase is displaced by angle theta from the axis of the stator phase. Okay, so this is the displacement between rotor axis and stator axis. Okay, so the stator has got 3 windings, 3 coils, A dash, AS dash, BS dash, CS and CS dash is on the stator. Okay, and these are the rotor windings. Okay, which are either connected in star or delta. So A, and this is displaced by an angle theta. Okay, so this is AS axis and this is AR axis. So they are displaced by theta degree. Okay, so now we will write the voltage equations. Okay. So voltage applied to a coil, so we know that so V is equal to resistance drop R into I plus del D by dt into flux linkage. Okay, so it is the rate of change of flux linkage. Okay, with respect to time. So this is the general equation of voltage when a voltage is applied to a coil. So here we have 6 coils, 3 on the stator side and 3 on the rotor side. So we have to write 6 voltage current relations. Okay, so the first for rotor, that is stator. So this voltage across this coil is VAS. Okay. Current is IAS into drop in this resistance is RS plus D by dt into flux linkage. And the flux linkage in this winding is psi AS. Okay, and here IAS RS plus let D by dt is equal to a differential operator P. So this will be P psi AS. Okay, so VAS. So these are instantaneous values of voltage and current. So this is the voltage equation for phase A. Similarly, we can write for phase B. Okay. So for phase B, VBS will be equal to, so this is VBS, current flowing is IBS into RS plus P times plus linkage in stator winding of phase B. This will be VS. Similarly for phase C, so VCS will be equal to ICS RS plus P psi CS. Okay. So what we will do, we will find the values of this flux relation. Okay, for the flux linkage. So this is for stator. So similarly, we can write for rotor also. For rotor. So voltage is VAR, current flowing is IAR, and resistance is RR. Okay, plus P psi A flux linkage to the rotor base A. For VR, VBR will be equal to IVR RR plus P psi B, and VCR will be equal to ICR RR plus P psi C. Okay. So this is the voltage equation for the rotor, and this is the voltage equation for the stator. Okay. So first we will find the flux linkage. Okay. So this RS is stator resistance. Since it is a symmetrical induction motor, we are considering this as balanced winding. So these resistance are same. Okay. And RR is rotor resistance. So it is equal to same in all the. Okay. And psi is the flux linkage. Okay, so we have got 6 windings, and they will have their own self-inductance and mutual inductance with respect to each and every windings. Okay, and only the mutual inductance between the stator and rotor phases changes as the rotor rotates, as they are function of the theta. Okay, so the mutual flux of stator and rotor will change with respect to the movement of the rotor, as it depends on the rotor angle theta. Okay. So now we write flux linkage flux linkage equations. We start from stator. Okay. So flux is equal to the flux linkage on the phase arises due to self flux plus mutual flux. SI is equal to L into I, and equal to N into L. Okay, so this is the value of psi. So this is flux linkage. So L is this flux linkage of the stator is due to self flux and mutual flux. Okay, so this self flux is due to the own flux. Okay, so this is due to its own flux, and its mutual flux is due to when current flows in another winding. Okay, so all other winding, and this flux linked with the flux of this other windings of the stator and rotor. Okay, so we will have both self flux and mutual flux. Okay, so mutual flux linkage between one stator phase and another stator phase, okay, and with rotor phase also. So first we will find the flux linkage of phase A. So this is psi AS, this will be psi BS, and this will be psi CS. Okay. So first psi AS will be equal to the self flux. Okay. So that is L into I. So this will be L S. Okay. So we are assuming that the inductance of each phases are same. Actually, they are symmetrical. Okay. So that LA is equal to LB is equal to LC is equal to LS. Okay. So all this has got same inductance. Okay. And current flowing through this winding is IAS plus. So mutual flux when current IBC flows in this winding and when current IC flows in this winding. Okay. So let the mutual flux MAB. So this is mutual flux, mutual inductance between phase A and phase B is equal to MBC is equal to MCA is equal to MS. Okay, so let the mutual inductance between the two phases of this stator winding will be MS. Okay, so this will be MS. Okay, so when current flows in B winding, B phase, so this will be BS and plus ICS. Okay, so when current flows in this both coils, so this will be MS mutual. Okay, so this is inductance plus current. So this mutual flux is due to when current flows in B phase and C phase plus a mutual flux. So this will interact with rotor circuit also. Okay, so this will interact with this RR. Okay, phase A, phase B, and phase C. Okay, of the rotor. So let the mutual inductance between the stator and rotor as Ns. Okay, so the current flowing in this winding is IAR. Okay, but it is displaced by an angle theta. Okay, so it is displaced by an angle theta. So this is phase A, phase C of the stator, windings are displaced by angle theta. So this is an angle. So this is the stator winding and this is rotor. So it is displaced by an angle theta. So the current in this winding is AS and in this winding it is AR. So this is displaced by 30 degree. So if you project on this rotor axis, this will be cos theta. Okay, plus IBR. Okay, so this is IBR. So this will be theta plus 120 degrees. Okay, so this will be cos 120 plus theta plus 120 plus ICR will be cos. This angle will be theta minus 120 degree. This will be theta minus 120 degree. Okay, so this is the equation flux linkage of stator winding. Okay, so this is flux linkage of stator AX. Similarly, we can write the flux linkage equation for phase B and phase C of the rotor. So psi Bs will be equal to self flux. So we have taken Ls and current will be IBS. Okay, plus the mutual flux. Okay, so this will be mutual inductance MS and current will flow to winding A and B. So this flux is due to the current flowing in this flux linkage is due to mutual flux between phase B and A. So this will be IAS, then this will be ICS. Okay, plus MSR. Okay. So current IAR. So now current is flowing with BS. Okay, so this will be current BS. Okay, and current AR is this. Okay, so AR. This is AR. This will be cos theta minus 120 plus I BR, it will be cos theta. Okay, so this is phase BR and this is BS. So angle between this is theta degree. Okay, plus ICR cos theta plus 150. Similarly, for flux linkage of C, ICS will be equal to LS, current will be ICS plus MS, IAS plus IBS plus MSR, AR cos theta plus 120 plus IBR cos theta minus 120 degree plus ICR cos theta. this is VR axis and this is VS axis. The angle between these two is theta. Okay, so in this way we can write the flux linkage of the stator windings. Okay. Now similarly we can write the flux linkage of rotor also. Okay. So flux linkage of rotor phase A, this will be same phi A R. Okay, let the inductance, self inductance is L R. This will be I A R plus M R. Okay, mutual inductance, and this will be I B R. So here S will be replaced by R. Okay. So IBR plus ICR, and this will be MSR. It will be same. MSR is equal to MRS. Okay. So into current is now this will be due to current flowing in stator winding phase A. Okay. Plus cos theta plus IBS cos theta plus 120 degree plus ICS cos theta minus 120 degrees. Okay, so this will be similar, only this will change from S to R. For phase B, IBR will be equal to LR IA IBR plus MR ICR plus IAR plus MSR IAS cos theta minus 120 degree plus IBS cos theta plus ICS cos theta plus 120 degree. Similarly for phase C, this will be RLR ICR plus MR ICR is A plus IBR plus MSR IAS cos theta plus 120 degree plus IBS cos theta minus 120 degree plus ICS cos theta. So these are the flux linkage equation of the stator and the rotor. Okay. So the current condition IAS plus IBS plus ICS is equal to 0, and IAR plus IBR plus ICR is equal to 0. Okay, so let's suppose this equation. So this will be psi AS is equal to LS IAS. So this is IBS plus ICS. From here we can write IBS plus ICS is equal to minus IAS. So this will become ms into IAS, okay, plus MSR IAR cos theta plus IVR cos theta plus 120 degree plus ICR cos theta minus 120 degrees. Okay, so you can take IS common, so this will be LS minus MS into IAS plus MSR IAR cos theta plus IVR cos theta plus 120 degree plus ICR cos theta minus 120. Okay. So we can write like this. Okay. So let LS minus MS be L11. Okay. So let's this LS minus MS is equal to 1. Okay. So we can write this equation psi AS here. So this will become psi AS is equal to L11 into IAS plus MS IAR cos theta plus IVR cos theta plus 120 degree plus ICR cos theta minus 120 degrees. Okay. Now similarly here this is IAS plus ICS. Okay. So we can write it as minus IBS. Okay. So that so IBS will be equal to LS IB. Sorry, this will be ILS minus MS into IBS. Okay. So IAS plus ICS is minus IBS. Okay. So plus MSR IAR cos theta minus 120 degree plus IVR cos theta plus ICR cos theta plus 120 degree. Okay. So similarly we can write for this base C also. So this will be minus ICS. Okay. So directly we can write ICS is equal to LS minus MS into ICS plus MSR IVR cos theta plus 120 degree plus IVR cos theta minus 120 degree plus ICR. Okay. But we have assumed LS minus MS is equal to L11. Okay. So we can write this equation as L11. So this will be L11 into IBS, and this will be L11 into MS. Okay. So we can reduce the flux linkage equation like this. Okay. So similarly, we can do it for the rotor side also. Okay. So this IVR so IAR plus IVR plus ICR is equal to 0. So IVR plus ICR will be equal to minus IAR. Okay, so this can be written as minus IA. Okay, this can be written as minus MR IVR, and this will be IC minus IC. Okay, so taking LR minus MR common here, so that LR minus MR is equal to L. Okay, so this flux linkage equation for the rotor side can be written as, so this psi AR will be equal to L22 IAR plus MSR IAS cos theta plus IBS cos theta plus 120 degree plus ICS cos theta minus 120. Okay. Simply you can write more phi A phi BR will be equal to L22 IBR, and for C plate this will be equal to IC. Okay. Plus MSR IAS cos theta minus 120 degree plus IBS cos theta plus ICS cos theta plus 120 degree plus MSR IAS cos theta plus 120 degrees plus IBS cos theta minus 120 degree plus ICS cos theta. Okay. So these are the Flux linkage equations for the stator, and this is for rotor. Okay. So now we will now use DQ transformation. Okay. So according to DQ transformation, so if you want to write the equations, so IAB, IB, and IC. For S, the stator side will be equal to cos theta minus sin theta cos theta minus 120 degree cos theta plus 120. This is minus sin theta minus 120 degree minus sin theta plus 120. This is 1 this is VS, LQS, and IS. Okay. So we can transfer the three-phase symmetrical induction machine into two-phase machine versus machine. Okay. So yesterday we have seen that this can be transferred into imaginary two-phase machine. This is dx is the stator. So current is flowing is IDS, and voltage across this is VDS, and this is small stationary axis or quasi stationary axis. So this will be Q axis stator winding. Current flowing through this is IQS, and voltage across is VQS. Okay. So from here we can write the values of IAS is equal to cos theta into IDS minus sin theta into IQS. Okay. We will not take these zero symmetrical components. Okay. So this is IAS, then we can write IDS will be equal to like this, IDS cos theta minus IQS sin theta, and IDS cos theta minus 120 degree. So we are transferring the IABC into ID, okay, minus IQS sin theta minus 120 degree. So from cos transformation is IDS cos 240 degrees 120 degrees minus IQS sin theta plus 120. Okay, so you can transfer these three currents, three phase current into two phase current. Okay, like this. So now we will substitute these values into the rotor side. Okay. So similarly, we can write this is for stator. So for rotor, IAR will be equal to IDR cos theta minus IQS cos theta. IBR will be equal to IDR cos theta minus 120 degrees minus IQR cos theta minus sin theta. ICR is equal to IDR cos theta plus 120 degrees minus IQR sin theta plus 120 degrees. This is for this. Okay. So for rotor, so this will be two pseudo-stationary windings. Okay. This is the axis rotor winding. Okay. So the three phase of the rotor, which is connected to the star, is converted to these two positive stationary windings. So this is the axis rotor winding, and this is two axis rotor windings. Okay. So current going through this is IDR, and in this it is IQ. Voltage is V2R. So this will be IB, VD. Okay. So now we will substitute the values of IAR, IBR, and ICR here. Okay, and we will realize the flux linkage in terms of ID and IQ. Okay. So the equation. So this is very lengthy equation. So to convert to or to make easier, we are changing this three phase into two phase. Okay. So let's substitute the values of this IAS and IBS and ICS, and IAR and IB are in the flux linkage equation of the stator. So psi AS is equal to L11 into IAS plus MSR IAS into cos theta plus IBS cos theta plus 120 degrees plus ICS cos theta minus 120. Okay. So this is the value of flux linkage of stator phase A. Okay. So now we will substitute the values of this will be R. Okay. So IAS is this much. So this will be equal to L11 into IDS cos theta minus IQS cos theta sin theta. Okay. So this is AS axis. So this is AS axis, and this is AR axis. Okay, and angle between the axis. Let the B axis. This is the B axis, and this is the Q axis. This is Q axis, and this is B axis. Okay. Now let the angle between D axis and is theta r, and D axis and stator axis as theta x. Okay. So this is the transformation of the stator to D axis. So angle between IS and IDS is theta s. So this will be equal by theta s. Okay, so this is stator phase axis, and this is rotor phase axis, and this is D axis. So angle between D axis and stator phase axis is theta s. So this is the transformation between stator and dq variables. Okay, so this is replaced by theta s, and rotor axis, the angle between D axis and rotor axis is r. So this will be replaced by theta r, theta r, theta r, theta r, theta r, and theta. Okay, so this is equal to theta s. Okay, and then plus MSR IAR cos, sorry, IAR is this much, IDR cos theta r minus IQ, IQR sin, IQR sin theta r. Okay. So this is the value of IR multiplied by cos theta. Okay. So this will be for stator cos theta s. This will be cos theta s. Okay. Plus IVR, this is IVR, is IDR cos theta r minus 120 degree minus IQR sin theta r minus 120 degree multiplied by this angle cos theta s plus 120 degree. Then we have to substitute here ICR is IDR cos theta r plus 120 degree minus IQR sin theta r plus 120 degrees whole multiplied by cos theta s minus 120. Okay, so this is the value of psi s in ID and IQ. Okay, so now on solving this equation, we will get I is equal to L11 IDS cos theta s minus IQS sin theta s, and this whole term will be plus 3 by 2 MSR ideal cos theta minus IQR sin. Okay. So on solving this whole term, you will get 3 by 2 MSR IDR cos theta minus IQR sin theta. Okay. So let L12 be 3 by 2 MSR. Okay. So this equation will be found. IQS will be equal to L11 IDS cos theta, this will be theta minus IQS sin theta plus L12 IDR cos theta minus IQR sin. So phi as psi as, and so taking cos theta common here, so this will be L11 into IDS plus L12 IQS minus into cos theta minus L11 into IQS plus L12 into mode multiplied by sum. Okay. So let psi ds is equal to this value, psi ds is equal to L11 IDS plus L12 IDR and psi QS is equal to L11 IQS plus L12 IQ. Okay. So this psi AS will become psi ds cos theta minus psi QS into sin theta. Okay. So similarly, we can write for psi in the B and psi BS and psi CS. Okay. And for rotor side, so this is for stator, and for rotor, similarly we can find pi dr will be equal to L11 I dr plus L12 I ds qr L11 IQR plus L12 ID IQS. Yes. Okay. So this is the flux linkage in D axis and Q axis of the pseudo-stationary windings of the stator, and this is for the imaginary windings, stationary windings of the rotor. So similarly, you can write the values. Okay, so these are the flux linkage equation of the three-phase symmetrical induction motor using D2 rotors.